Alrighty. So there was, I think, a good number of people were struggling with how to deal with the Hill 2x2 matrix, and specifically kind of inverses and things like that, and that's fair. So um, finding inversion modulo something is something kind of from module 2. So the thing to do is inverse of a 2x2 matrix in Google. Take a look at anything, and there it is. So the question is, how does this change when my math is all sort of 0 to 25 mod 26? Negative doesn't exist, so you have to add 26 because these were all sort of things that came from letters, right? Then the other part is this 1 over. So this is a scalar multiplication, but again, when you're working modulo 26, you're not allowed fractions. So what you have to do is find the modular inverse of AD minus BC. So I'll take and sort of walk you through how you could calculate the inverse of a 2x2 matrix in Hill real quick, and when it will work and when it won't, mod 26. And we'll do this one, 25, 3, 9, 20, and spit out 4, 15, 19, 5, and see how that goes. And I'm guessing that this one's a problem partially because the stronger your math background, the easier it is. So maybe my description here is very light. And the weaker your math background, the more frustrating that's got to be for you. Okay, so here we go. I'm going to do, I like to use the crypto library just to kind of have inverse. So for instance, the inverse of 9 mod 26 is 3. So why is that? Well, that's because 9 times 3 mod 26 is 1. Hold on 1 second, I'm getting called. All right, my 1-year-old just pooped in the tub. Yeah, gross. Ew. All right, so let's say that our entries, because I know this is a 2x2, I'm not going to make this like the most well-engineered thing, but I'm going to say 25, 3, 9, 20. 25, 3, 9, 20. Great. So what am I saying here? If this is A, B, C, D, in that order, and the thing we're looking at is kind of this, A, B, C, D, we want AD minus BC. So this is called the determinant, by the way. Entry 0 times entries 3 minus entries 1 times entries 2. Okay. Now we should look at that mod 26, of course. And we should look to see, is there an inverse of 5 mod 26? And here the answer is 21. Why? Because 21 times 5 is just a little bit over a multiple of 26. Great. So that's, 26 times 4 is 104, 105 is 1 past that, etc. So all we need to do then to get this modular inverse, so we could say def invert me, takes in A, B, C, D, and I could say the modulus. Why not? All right, so let's say determinant equals A times B minus B times C. And maybe I could do this modulus now. Okay. We could say if the GCD of the determinant and the modulus is not equal to 1, then return, false or something like that. Like it just can't be done. And that's basically if it shares any factors at all with the modulus, then there's not going to be an inverse. And you can kind of see the module 2 notes for bigger details in that or whatever. Okay, so then we have the sort of inverse determinant will equal the inverse of the determinant mod the modulus. All right, and so then we just kind of return, what do we got? D, negative B, negative C, A. So D times inverse determinant mod modulus. And here we could do inverse determinant times modulus minus, was it B? On the modulus. That's negative B. And that was my way of, modulus minus B is the same thing as negative B. Inverse determinant times modulus minus C mod the modulus. And finally, inverse determinant times A mod the modulus. Okay, so and here's a little Python-y trick. I could, I think I could just do this and that'll work. 415, 19.5. And here's the notes, 415, 19.5. Okay. And if you want to kind of confirm that, if I were to def write multiply, it takes in entries and a kind of column vector. I'm going to take the first entry of the column vector multiplied by the first column of the entries plus the other thing. So I'm basically just going to return, oh, I guess I need the modulus. So I can return, let's see, the first entry in the quote column vec, which I'm just going to give an array of 2 entries here, will be column vec 0 times column vec 0 times entries 0 plus column vec 1 times entries 2, and all of that is mod the modulus. And then the other entry will be column vec 0 times entries 1 plus, oh, I'll want my parentheses again. Column vec 0 times entries 1 plus column vec 1 times entries 3 mod modulus. Okay. All right, so that's sort of a matrix vector product. So I could multiply my entries by 0, 13, right, 26, and likewise, what's the other one I have? 17, 13. Oh yeah, dy is d is the 0, 1, 2, 3, and y is second to last, and 25 is the last of 24. That's 521. Here I'm getting 17, 13. Okay, so 314. Maybe I've gotten off by 1 error there. 13, 18. And what do I have as board of R minus board of A? 17. That doesn't feel right. Did I change entries by chance? 25, 3, 9, 20, 25, 3, 9, 20. So if I've got 3 times 25, 75 plus 24 times 3. 147 mod 26, 17. Yeah, I buy that. Oh, that's what I did wrong. I think my formula, I made this 0, 2, and it should be 0, 1, and 2, 3. So, and that's why you double check these things. All right, entry is 0, column 1, entry is 1. All right, so I want kind of the first row, kind of the dot product with the first row, and the dot product with the second row. Okay, so now that was fine for the other one because I had sort of zeros involved. There's my RN. Okay, cool. Yeah, so that's it. As just a fun fact, if you take the, I had this sort of inverse, right, of invert me. By the way, this trick, I'm sorry, I should not leave it be. This invert me, the way I wrote it, had sort of A, B, C, D modulus as the arguments. My little trick is that if I put star entries, that doesn't make any sense, but if I put it into a function, that is, I think, the spread operator, and it takes the array and turns it into just a non-array entity of arguments. But also, if I have an array and I add some other thing, so I took entries plus 26 to get 5 arguments, and then put the star operator to get the invert me. Anyway, so there's invert me. Inverse m equals that. Just for fun, I can take kind of the multiply, take the original matrix, and I can take the column vectors of that inverse, 4, 19, and that should give me 1, 0. And if I take the other column vector, which is 15, 5, that will give me 0, 1. You know, and that shows me that my inverse spits out the identity of mod 26. Okay, in terms of how to use that to break your Hill cipher or whatever, you can more or less say, like, if I've got some ciphertext, whatever, ZG, whatever, something. If you presume that these 4 are equal to, like, that, T-H-A-T, you can use that to just spill out what the matrix would be that would give you that. The other thing is you could just brute force, so you could probably, I think 26 to the 4th is not too bad. Yeah, less than 1 million. Yep, time to go. All right, gotta go. Stop recording.